So good morning dear students. So welcome to the next lecture. In the last class we have discussed about orthographic projection. So we are left with two things, that is oblique projection and axonometric projection. So we will finish today those two things, right? Oblique projection, right? So oblique projection, let us take an example to understand this. Suppose this is an object, correct, and let us say this is a POP, plane of projection. Suppose this is POP, plane of projection, correct. Now so these projectors are, you can see that it is parallel to each other, right? This is the observer, right? Now fine, suppose this is A, suppose this is A and let us say this is B. So its projection will be A and its projection is B, correct. Let us say this is C and let us say this is D. So its projection will be C, isn't it? So in oblique projection what you can observe is, in oblique projection what you observe is this angle alpha is less than 90 degree, isn't it? Alpha is less than 90 degree, correct. So if you want to draw for D also you can draw it, but it will look a little, so let me try it. Right, so this is your D, correct. So you can see that all these angles isn't it? You can see that this angle is nothing but your alpha. So you can see that this angle alpha, it is less than 90 degrees. So it is called as oblique projection. In orthographic projection, alpha was 90 degree, isn't it? In oblique projection, rays are parallel, or you can see that the projectors are parallel to each other, but the angle it is making with POP is less than 90 degree. Such type of projection is called as oblique projection, correct. So you can see that the face ABCD, when I project it, when I am projecting it, so A, B, C and D, isn't it? So draw till here. RP, POP always front view, sir, with respect to observer. Here this is your front, right, because this is the vertical plane. So I have drawn the projection projection in the vertical plane, right. So for this is the vertical plane, correct. Now this BC line, this BC, it is the actual length. BC is your actual length, correct, and small bc, it is called as receding length. It is called as receding length, correct. BC is your actual length, but its projection B and C, small b and c, it is called as receding length. Now this AB exactly you will see the same size, but this BC and this length it will change. Isn't it? Yes, this is the first slide, right. So what is, there are 2-3 points on which the question has been asked. The first point is about the oblique projection itself. So what is oblique projection? Oblique projection is the projection in which oblique projection is the projection in which the parallel projectors intersect POP at an angle alpha less than 90 degree, such that one face of the object is parallel to that POP. correct? You can see that observer is here, right? So that means it is some situation is something like this. Situation is something like this. If I am taking a projection like this, it will become orthography because it my eyesight or the rays that is coming from my eyes is exactly perpendicular to POP. But if the object is placed like this or object is placed like this, correct? So ray of vision will be inclined. So it will make certain angle with your plane of projection. So that is basically called as oblique. The rays are still parallel to each other. You can see that the rays are still parallel to each other. Rays are still parallel to each other. आपको दिख रहा होगा? Rays are still parallel to each other. Isn't it? Okay. So this object has is parallel to one of the POP. So that means the object should be placed such that this face must be parallel to POP. For you, if I am holding it like this, so the ray of vision is exactly parallel to POP. But if I place it like this, or if I place it like this, how you will see? You will see upward, है ना? You will see upward like this. So this face is parallel to POP, but the rays are inclined to POP, isn't it? So you can see that this ABCD. So you can see that if I call it as A dash, suppose if I call it as A dash, B dash, C dash, right? So you can see that C, C dash, D, and there will be internal D dash. So C, C dash, D, D dash is parallel to POP, right? Okay. Next point. If alpha is equal to 45 degree, then the receding length is same as actual length. Is same as actual length. Such projection is called as Cavalier projection. Similarly, if alpha is equal to 63.26 degree, then the receding length is half of actual length. Such projection is called as cabinet projection. Done. Fine. I hope things are clear. So that was your oblique projection for you. Next, the last projection is your axonometric projection. So I hope everybody has written and all the things are clear. This is called as receding length. This the projection of, see, this is BC. BC's projection, it will change its distance, right? BC is like this, horizontal, and its projection is vertical. So this length and this length will change. So at alpha equal to 45 degree, that means if the ray of vision is at 45 degree, this length will be exactly this length, right? So we are not going to prove it. हम यहाँ पे prove नहीं कर रहे. Clear? Okay. Done? Now coming to the axonometric projection. In axonometric projection, the first one we have is called as isometric projection. Isometric projection. So in isometric projection, object is kept at its corner such that isometric axis makes equal angle with the POP, right? So in isometric projection, object is kept at a corner such that the isometric axis makes equal angle with plane of projection. For example, see, this is a cube. Let us say we will take a simple example. This is the cube. You can see that only this face, right? Only this face is visible. This face and this face is not visible. So what I will do? I will tilt it like this. So now this face and this face, both face are visible. This face as well as this face is visible, correct? To see this face, what I will do? So I will topple. I will place it at one corner, right? See here. ठीक है? So let us say this is the object, it is kept like this. Now I am putting it like this. So this face, both face are, you can easily see. Let me topple it at its corner, this corner. if I do it like this, this face and this face, all the three face will be seen, isn't it? This face and the top face, it will be easily seen. So such type of projection is called as isometric. Now in isometric such that see when I topple it like this, right, so this is one axis, this is another axis, and this is another axis. So these three axes must make equal angle with POP, right? So you know fine, so it is something like this, correct? So this is one isometric axis, this is another isometric axis, and this isometric axis. So these three axes must be equal to must make equal angle with POP, correct? Now moreover, iso means equal, metric means length. So such that this length, this length, this length, these three lengths are also seen to be equal of length, right? For example, suppose this is 3 centimeter. So from the front it will look 3 centimeter, but if I do like this, right, equally inclined to vertical plane, that means this angle and this angle is same. So this length and this length will look equal, but it will not look 3 centimeter. 3 centimeter it is like this. If you change it, it will be reduced from 3 centimeter. Let us say it is 2 centimeter, right? So this length it will look now 2 centimeter, 2 centimeter, but this length is how much? So you will say that this length is still 3 centimeter, isn't it? So this is 2 centimeter, this is 2 centimeter, this is 3 centimeter. So I need to decrease this length. So what I will do? I will topple it like this, correct? If I topple it like this, now at certain angle, this two, it will be seen as it is. Now this length will start to decrease, because as you topple it, its length will be, as when you see it, this length will be not same as it was, it will be reduced. So let us say it is 2 centimeter. So for this angle and this angle must be same, then only this length, this length, this length will be equal. So this angle and this angle, if it is same, so that means all the three sides will become equal. Such type of projection is called as isometric projection, right? So how the object will look? This will be seen, this will be seen, and this portion will be seen, isn't it? So let me draw it. So in isometric projection, the object is something like this. Fine. So let us call it as O, A, B, C, D, correct? Now what I am saying, that this angle must be equal to this angle. If I consider this angle to be, suppose, angle A, and this angle to be angle B, right? Moreover, this is the isometric axis. This is called as isometric axis, right? So this is Y, this is X, and let us say this is Z, correct? So X, Y, Z, it is called as isometric axis. It is called as isometric axis, correct? So this is the value, okay. Now if, what is the example? Now condition for isometric is, so this is important to understand. Condition, this OA, it should be equal to OB, it should be equal to OC, correct? So that means all the three sides should be equal. Isometric. Isometric means, sir, is axiometric projection is the first topic of today's class? No, we have discussed oblique projection. Oblique projection already we have discussed. We are in the next isometric, the second part, right? OA, OB and OC, correct? So if OA and OB and OC all are equal, it means that what will be this angle? So let us call this angle as alpha, let us call this angle as beta, and let us call this angle as gamma, correct? So if all the three sides are equal, if all the three sides are equal, so included angle will be also equal. Isn't it? Fine. So you can see that isometric, all the three edges are equal, right? So this included angle will be also equal. So alpha will be equal to beta, it will be equal to gamma, and it will be equal to how much? 120 degree, isn't it? Fine. And angle A, it should be equal to angle B. Now the question is how much this angle should be, right? This angle, it is equal, correct? Now my question to you is how much this angle should be? Angle A and angle B कितना होना चाहिए, right? So I hope all the points are clear. Isometric means all the length should be same. All the length should be same means OA, OB, OC, it should be same, right? So when you project it, the total angle it should be 360 degree, right? So when you project the object on this POP, so you will get the total angle is 360 degree. Since all the sides are equal, so it will also have the equal angle included. So alpha plus beta plus gamma is equal to 36 degree, 360 degree, and all the sides are equal, so all the included angle will be same. So alpha beta gamma is how much? 120 degree. Now this angle A and angle B will be same. Why? Then only this OB will be equal to OA and OC. So my question to you is how much this angle A and B will be, right? So for this what I will do is, okay, one more thing that you can see over here is, so angle A and angle B I have to find, correct? So angle A and angle B, if I want to find, then what I have to do is, let us draw a line which is exactly parallel to the bottom line. Correct? Now you can see that this angle, okay, better if I draw in the see what should be the angle, see here very carefully. Correct? Now if I draw a line such that this is parallel to this, correct? Now this angle is how much? You will say 90 degree. This angle is 90 degree. And how much is this angle? So this angle will become 30 degree, isn't it? Because this is 120, total angle is 120. So this is B, this is O, this is C. So if this is 30 degree, how much will be this angle? This angle must be at 30 degree, isn't it? So that means this angle A and angle B will be same, and this should be equal to 30 degree. So this becomes the condition for isometric projection. बताओ समझ में आया? So this is the condition of isometric. So in the exam directly they will ask you the condition. Fine. So for isometric, all the three sides should be same. Included angle should be 120 degree, and the angle by which I have to topple the object is your 30 degree. Kasturi Das is correct. Anup Malik is also correct. Clear? Okay. I hope it is clear. Now we have certain points, we will write one by one. बताओ यहाँ तक क्लियर है चीज? Clear? Adab sir, then what about isometric views are drawn at 45 degree? Sabar, Sabar, Mr. Adhav, है ना, सबर कीजिए, सब पता चलेगा, रुक तो जाइए, अभी तो शुरुआत है, डरने की क्या बात. Correct. Now see some important points. The first point, listen very carefully. See, this is your isometric projection of an object. Correct. Now I said that this is your isometric axis, x-axis, this is your y-axis, and this is your z-axis. Correct. I also said that this is O, this is A, this is B, this is C, and let us say this is D. If I can complete it, if I can complete this one, right. So let us say this is your A dash, right, something like this, correct, and this will become your O and D dash are coinciding at one point. Now I said that XYZ is nothing but your isometric axis, isn't it? That is what I told you. XYZ is nothing but your isometric axis. Isometric axis, correct. Now this BC line, correct. Now just tell me one thing, how much is this angle? You will say that this angle is 30 degree. So how much is this angle? You will say it is 60 degree, isn't it? Because it is a straight line, so 60 degree. So if this is 60 degree, okay, fine. Then how much is this angle? Okay, this angle is 60 degree. Similarly, this angle will be 30 degree and this angle will be how much? 60 degree. So how much is this angle? You will say it is 120 degree. Why? Because this is 60, this is 120. Now AA dash and OB are parallel to each other. So it has to be 180 degree. So 60 degree, this should be 120 degree, isn't it? So this should be 120 degree. Correct. So 60 plus 120, it is 180 degree. So 180 degree means OB and AA dash are basically parallel to each other. Correct. Clear till here? Okay. So this line BC, right, it is parallel to the isometric axis. Similarly, AA dash, it is parallel to what? So AA dash, it is parallel to, and BA dash, it is BA dash, it is parallel to OA. AA dash, it is parallel to OB, right? So that is why. So any line parallel to the isometric axis is called as isometric line, right? So BC, it is parallel to isometric axis. Then AA dash, correct, then BA dash, etc., BA dash, etc., or you can say that it is clear. So first point, isometric axis makes 120 degree. So isometric axis, you can see that it is very clear here also. So this angle, and this angle. So this is your 120 degree, this is also 120 degree, and this is also 120 degree, isn't it? So isometric axis makes 120 degree with each other, but isometric lines, that is line parallel to isometric axis, line parallel to isometric axis, like BC, BA dash, AA dash, etc. either makes 60 degree or 120 degree, isn't it? correct. So it either makes 60 degree or 120 degree to each other, isn't it? तो आपको दिख रहा होगा, correct. So you can see that, okay, so this is 120 degree, how much will be this angle? It will become 60 degree. If this is 60 degree, how much will be this one? This will be also 60 degree, isn't it? You can see that. Clear? So either it will make 120 degree or it will make 60 degree, correct? Shobhit Tyagi, in oblique position, if alpha is less than 45 degree, yes, correct, Shobhit. Fine. Next. Clear? Second, isometric scale. Isometric scale. So let us understand what is the meaning of isometric scale. बता यहाँ तक clear? ठीक है, देखो आइसोमेट्रिक स्केल क्या होता है ये समझो. सपोज let us say this is TL, true length, correct. Suppose this is O, this is A, this is B and this is C, correct. TL means true length. TL का मतलब होता है true length. Now see very carefully. This is a cube. What is the this is the true length, that is 3 centimeter, 3 centimeter, everywhere it is 3 centimeter. What is the actual angle? You will say it is 90 degree, true angle. So true angle is how much? It is 90 degree. So that means if the true angle is 90 degree, it means that this angle is how much? It will become 45 degree and this angle will be also 45 degree, isn't it? So this is the true angle, correct. So this 45 degree is a true angle, correct. Now when it is tilted, right, when it is tilted, now it becomes something else. See what it becomes. Correct. Now this angle is becoming 120 degree. O, A, C and D. Oh sorry, it was C. ये हमने C ले रखा है, ये D है ना, क्योंकि B तो नीचे. Now this length is how much? This is our iso length, that is isometric length, isn't it? Iso length. This is 120 degree, so how much this angle will be? This angle will become 30 degree and this angle will become 30 degree. होगा कि नहीं? Correct? So ये 120 डिग्री बना रहा है ना, तो ये भी आपका 60 डिग्री बनेगा. This is also 120 degree. You can see here that this alpha is making how much? 120 degree. So how much will this one? This will make 60 degree, isn't it? Correct? अगर ये 120 बना रहा है तो ये एंगल कितना बनेगा? 60 डिग्री तो बनेगा. Right. So if this angle is 120 degree, this will be 60, this will be 60, and this is angle will be also 120 degree. So this length is called as isometric length. Right. So this is your iso length. Clear? Now there is a relation between this true length and iso length. This true length is at 45 degree and this iso length is at 30 degree. It means that when you are going to topple at its corner, that means when the object is toppled at its corner, the length is changed. This is the actual length. This is the actual length. When it is toppled, the length will change. By what factor the length is changed? That is called as isometric scale. Right. By what factor the length will change is called as isometric length. So now this is the two situation that is created. Right. So ये है before toppling. Right. So this is the before placing at the corner. This is after placing at the corner, isn't it? So initially the object is kept like this. After toppling at the corner, so this is your before placing at corner. This is after placing at corner. After placing at corner, isn't it? So now see very carefully. This is A, this is C, there is no doubt. ध्यान से देखते रहिएगा. This is at 45 degree, true length, correct. So let us say this is your A, so let us say this is D, fine. This is the true length, correct. And what is the angle at which I have drawn? So this angle is at 45 degree, there is no doubt about it. This is AC 45 degree, right. Next I have let us say this is D dash, correct. So this is your iso length and this is drawn at what angle? So this is drawn at 30 degree and this is your iso length, correct. You can see that iso length with respect to AC, it is drawn at 30 degree. Let us call this point of intersection as D double dash, correct. Now what I can make it out from here is that AD double dash is equal to AD cos 45 degree and AD double dash it is also is equal to AD dash cos of 30 degree. You can check it out, है कि नहीं. देखो यही दोनों को हमने सुपर इम्पोज कर दिया. So we have superimposed these two figures and we are getting this one, right. So AD dash AD double dash, it is your AD dash cos 30 and AD cos 45 degree. Both the length are same. So I can say that AD cos 45 degree is equal to AD dash cos of 30 degree. What is AD? It is true length into cos 45 1 by root 2. AD dash is how much? It is nothing but your iso length, iso into cos 30 root 3 by 2. So therefore how much is the iso length? So iso scale or iso length will be how much? It is equal to root 2 upon root 3 times of true length. This is approximately equal to 0.618 times of true length. It means, what does it mean? It means that when you are going to topple at 30 degree, the actual length changes by a factor of √2 by √3, है ना? So when you are going to topple it at the corner, the length that you are going to see, it is changed by 0.816, sorry, 0.816. बताओ क्लियर है यहाँ तक? Any doubt, anybody? Any doubt, anybody? बताओ क्लियर है चीज? Shreya Sinha, we have completed oblique projection. We have started with the axonometric. में isometric का भी हो गया है, तो मेरे समय से 2-3 स्लाइड्स हमने निपटा ही दिए, right? So those who are joining the late, right? So I will just show you. We have started from oblique projection. So this one slide we have completed, right? This is the second slide that we have completed the condition. This is the third slides almost we are going to complete, correct? So third slide का ये part हो गया and we are doing isometric scale, this one. So we are in the fourth slide. ठीक है, okay. So this is B. Coming to the C. Methods to draw isometric projection. To draw isometric. Right. So next we have शोभित त्यागी, फर्स्ट फिगर टॉप व्यू से देखेंगे ना सर। फर्स्ट फिगर कौन सा फर्स्ट फिगर? अच्छा, हाँ हाँ हाँ, राइट। इसमें जो पहला मेथड, इट इज कॉल्ड एज बॉक्स मेथड। बॉक्स मेथड, इट इज यूज्ड फॉर, या फिर इसको डाट, फॉर प्रिज्म non isometric lines, for prism, pyramid, you can say cylinder, and non isometric lines. Correct. So box method, it is used for prism, cylinder and non isometric lines. What is non isometric line? So let us understand ये नॉन आइसोमेट्रिक लाइन क्या होता है? देखो, so I have drawn an object, the red color, you can see that, isn't it? So if I consider this to be A, this is B, this is C, and this is D, right? So A, B and C, D is neither parallel to isometric axis. X हो गया, Y हो गया, Z है, correct. So here AB, CD is called as non-isometric lines, is called as non-isometric line because it is neither parallel to x-axis nor parallel to y-axis nor parallel to z-axis. So isometric lines are the lines which are parallel to isometric axis. If it is not parallel to isometric axis, it will be called as non-isometric line. AB and CD, it is neither parallel to x-axis nor y nor z. So if it is not parallel to x, y, z, it will be called as non-isometric. So you can see that I have, this is called as box method, right? So in a box I have completed the figure and this is how we have drawn it, right? Clear? So box method. ठीक है, समझ में? This is your box method. Obviously, but obvious this angle will be at 30 degree, there is no doubt about it, because we are talking about the isometric projection. So this angle will be at 30 degree. Second, it is called as 4 center method. Right, see 4 center method, it is used, it is for drawing a circle. 4 center method, it is used for drawing circle. For example, देखो कैसे, for example, suppose there is a circle, right, suppose there is a circle, you are being asked to draw the isometric of this, correct? So first what I will do, I will enclose this into a square. So put this square inside this circle. Correct? So let us name it. Suppose this is A, B, C and D. Correct? These are the midpoints. Let us say this is your 1. Let us say this is your 2. Let us say this is 3 and let us say this is 4. Correct? So 4 center method. So draw line. Correct? Now from here you point A and just make 30 degree. Correct? Right? Right. So this is A and this is B. Correct? At how much angle you have to make? We have to make 30 degree. Correct? Similarly, So this make it D, right? This should be also at 30 degree. Correct? So we know that isometric is drawn both angle at 30 degree. So AB make 30 degree and AD make at 30 degree. Now what you have to do is you have to complete this, right? So let us complete this one. Correct? So what is this shape? This shape is nothing but your rhombus. Correct? So this is your rhombus shape. This point is your C. Correct? ABCD done. Fine. So first of all I will do ABCD. Now I will take the midpoint. Correct? Let us say the midpoint to this, right? Let us say this is the midpoint. Similarly here this is the midpoint. Let us say this is the midpoint. Let us say this is the midpoint. Fine. So AB, this point is 1, this is 2, this is 3 and this is 4. So these are the midpoints. Draw it. Now from here what you have to do is you have to draw, mark as a center and draw two lines which is exactly like this. Correct? So you can see that this is one center. This becomes one center. Four center method means what? There will be four center. So first you draw ABCD. So AB at 30 degree, AD at 30 degree, right? And then complete. So you will get a square is converted into a rhombus, right? Take the midpoints as it is. We have taken A, B, C, D. You can see that these are 1, 2, 3, 4 are the midpoints. Just mark 1, 2, 3, 4 as the midpoints, right? From C, draw two lines which is passing through 1 and 4. Similarly, take this one, another this as a center, and from here draw a line which is passing through this 3 and one passing through this 2. Correct? So you are going to get two more centers. One more center here, another center here. Correct? So that means how many centers you have got? So if totally you have got four center. This is one center, two center, this is third center, this is four center, right? So there is four center. So that is why it is called as 4 center method. Fine. Now see, what you have to do is take your compass, put it here and take this and 3 as radius and cut an arc. So you will get an arc like this. Correct? Similarly, put your compass at A and take A3 as radius. Correct? A3 as radius and cut an arc. So if you cut an arc, you will get an arc something like this, isn't it? Similarly, take this as center and take this as radius and cut an arc. So you will get an arc like this, right? And take C as a center and C4 as a radius and cut an arc. So you will get an arc like this, isn't it? So the shape, I hope it is clear. So the shape that you are going to get is exactly like this. Correct? So what you are going to get? A circle is becoming an ellipse. A circle is becoming an ellipse, right? So take this as a center and take this as a radius, make an arc, center like this, arc like radius like this, make an arc, center like this, make an arc, center like this, make an arc. So you are going to get an ellipse. So here what we have understood is, so hence what is the conclusion we have drawn? Hence a square becomes what? In isometric. So isometric square, it becomes like a rhombus, isn't it? A square will look like rhombus. Then a rectangle, it will look like a rectangle, it will look like parallelogram, right? A circle, it looks like an ellipse. In isometric, a circle will look like an ellipse. A triangle, it will look like a scalene triangle. What is the meaning of scalene triangle? Scalene triangle is a triangle in which A is not equal to B, not equal to C. Neither of the sides will be equal. Correct? So this is the second method. Second. बताओ क्लियर है यहाँ तक? I hope things are clear. Isometric of a circle, 4 center method. So we have 4 center, and taking those 4 center, we have drawn a curve, and this curve is called as ellipse. तो आ गया अदरक हमारे पास. बताइए क्लियर है यहाँ तक? एनी डाउट टिल हियर? समझ में आ रहा है? तो आपको देखो हर चीज, यू डोंट हैव टू रिमेंबर एवरीथिंग, जस्ट फैक्चुअल पॉइंट्स, राइट? So in the exam they might ask you a question like this: what is the isometric view or isometric projection of a square? You will tick rhombus. What is the isometric projection or isometric view of rectangle? You will tick parallelogram. Or circle, you will tick ellipse. Now this question came this year. अभी आपको याद आया ये जो question आया box method, this is a question for this year ESE 22. They have asked which method is used to draw the non-isometric lines. So it is your box method. ये क्वेश्चन इस साल आया था, राइट? 21 में एक क्वेश्चन आया था 2021, इज द बेसिक डेफिनेशन ऑफ द आइसोमेट्रिक ओनली. व्हाट इज द मीनिंग ऑफ, मतलब बेसिक डेफिनेशन ऑफ द आइसोमेट्रिक, कि आइसोमेट्रिक होता क्या है, राइट? सो बेसिक डेफिनेशन इस पर 2021 में. सो इफ यू लुक एट द क्वेश्चन, so this kind of question they will ask you. They might ask you the condition, what is in isometric position, what is the angle made by the isometric axis? So it is 120 degree, right? So इस तरीके से चीजें पूछा जाता है. और they may ask you what is the isometric lines makes angle with each other, 60 degree, 120 degree, 60 or 120, like this. Right? They might ask you what is the isometric length, by what factor isometric length is as compared to the true length. You will say root 2 by root 3 or 0.81. So if you do the workbook you will come to know, right? So various types of question. तो इस तरीके से क्वेश्चंस इसमें पूछा गया. 2 क्वेश्चन पूछा गया 2022, इस साल भी आया था. सो दिस क्वेश्चन वाज ऑन द नॉन आइसोमेट्रिक लाइंस. 21 में बेसिक डेफिनेशन ऑफ आइसोमेट्रिक, राइट? तो इस टाइप से क्वेश्चन आपको देखने को मिलेगा, राइट? डन. सो दिस इज पॉइंट नंबर, ओके, 4 सेंटर मेथड है ना. थर्ड वन it is called as offset method. It is called as offset method. So it is used for drawing pyramid or cone. Pyramid or cone, right? So they might ask you these kind of methods. Which methods are used where? जल गया. सो ये कौन सा था? सी था. ना कमिंग टू द डी. isometric projection or view of a sphere. Isometric projection or view of a sphere. So देखो ध्यान से देखना, a sphere looks like a circle. A sphere looks like a circle of radius that of sphere, isn't it? A circle looks like a sphere looks like a circle of radius that of sphere. Means what? If I consider this to be the sphere, right? So this is the sphere. So what is the front? If you see from any side, it will look like a circle. If the radius is something of sphere, so circle will also have the same radius. तो जितना बड़ा sphere होगा उतना ही this will look like a circle of the same radius as the sphere is, right? We have to draw the isometric view and isometric projection. So from here you will see that there is a difference between isometric projection and isometric view. दो चीज आपको सीखने को मिलेगा. How to draw the isometric view or isometric projection of a sphere. Very important thing. And second thing, what is the difference between isometric projection and isometric view? So both the thing you will come to know over here, right? So for this, let us take an example, correct? So I will take an example. Let us take an orthographic projection. Let us take the orthographic projection. Fine. So let me consider this to be a sphere, correct, which is kept on a, so let me change this color. So let me consider this to be suppose 100. You can take any value, and let us say this is your 50, correct? And we have radius let us say we have spherical radius of suppose 10. Now this is the object. That means let us say this object is placed at one, okay, better if we take square, because I have a square over here, right? अरे यार क्या है? Let us say this is also 50, क्योंकि मेरे पास अभी फिलहाल स्क्वायर है, क्यूब है. Let us take this to be isometric. So I have to draw the isometric projection and isometric view of this particular object, right? Draw till here. Done? Now see, let us draw first isometric projection. Done, everyone? So, isometric projection. Isometric projection, we use iso scale. Iso scale means what? 0.816 times of true length we use. That means if anybody asks you what is isometric projection, so you will say that isometric projections are basically, okay, not about the definition, according to this particular figure I am saying that we have to draw at isometric scale. What is isometric scale? That means every length will be multiplied by a factor of 0.816, right? See, so let me show you. So this angle will be made at 30 degree. This is a 30 degree. If anybody is saying isometric projection, it means that you have to multiply all the length with 0.816. This is 50 into 0.816. This length, it will be 50 into 0.816. So all the length, that means if you are going to topple at 30 degree, if it is 50 centimeter actual length, you will be seeing only 40. 50 into 0.8, almost 40 centimeter, right? So that means actual, if it is 50, if I do the isometric projection, so that means the length will be reduced by a factor of 0.816. So if it is length of 50, how much you will see? It is 50 into 0.816. That is the meaning of isometric projection. Clear? Okay. So let me remove this part. Okay, or better, because I have to draw the sphere also, right? Now see, this is the thing that you will see here. So this is the basically your, now see very carefully. Now here comes the circle that I will draw it. Now see very carefully, बहुत ध्यान से देखिएगा. This is what? Cube that I have taken. You can see that there is a line I have drawn it, diagonal. I hope you are able to see it, है ना? देखो ध्यान से देखना. Just look it very carefully, because these things are basically you have to understand properly. This is the isometric. I have drawn it. So you can see that this diagonal is like this. This side is rhombus. This side is another rhombus. This side is another rhombus of equal length. Correct? This is how I have toppled it. Now this is the sphere that has been kept at the center. This is the isometric, this is the orthographic projection of this, right? You can see that this is the orthographic 50-50, and this I have kept it. Now when I am going to draw the isometric projection, so first I will tilt it like this, and then I will tilt it like this, so that it comes at the corner, right? So it will come at the corner like this, right? So one assistant is required, I guess. There is no assistant here. Compounder होना चाहिए था एक, right? So there is, this is the, you can see that this is how it is resting, right? Okay, no, not like this. Now this is how it is resting, right? So this is, you can see that this is the line that I have drawn it. This angle is 30 degree, this angle is 30 degree. What you are going to see, this line, you can see that. See, this is the sphere. Just put this sphere over here. This is how it will look like. This is how it will look like. Now if you watch very carefully, some portion of this sphere will come below this diagonal. This is a diagonal line. If you look very carefully, when I am placing at the center, some portion of the sphere is lying below this diagonal. देखो इस diagonal के ऊपर नहीं है. Some portion of the sphere it will look like as if it is lying below the diagonal. देखो ध्यान से देखो, just check it, है ना. So एक हाथ से पकड़ना थोड़ा सा मुश्किल है, थोड़ा सा आप भी adjust कर लो, समझ लो. See, this is how it will look like. Some portion of the sphere is lying below the diagonal, isn't it? Clear? You will say yes, clear. So that we have to draw it here. So if I talk about the center here, see very carefully. If I talk about this center, so center height is how much? This radius is 10, this height is 10, means it means that, so let us say there is a distance, right, let us say this is O, so you can see that O is here and this length will be how much? So if I ask you what is this length? Right, so this length will be 10 into 0.816, है ना. सेंटर भी तो इतना है, सामने का चीज क्या हो जाएगा, ये हो जाएगा. Now I have to draw a circle, so let us draw a circle such that some portion of the circle must lie below xy line, sorry, below this diagonal, right. So I am drawing a circle, right. This is the center, this is a 10 into 0.816, correct. So this is a circle you are going to get, isn't it? You can see that some portion of the circle is lying exactly below the diagonal. This is the center. It means that this circle will have the same radius as that we have seen. So that means this is your spherical radius, how much? 10, right. So this radius will be spherical radius, how much? It is 10. So this is the statement that I have just written. A sphere looks like a circle of radius that of the sphere. So actual sphere is of 10. So even if you tilt it, the sphere is looking same, so of the same radius. Some portion will lie just below its diagonal. It means that in isometric projection of a sphere, the size of the sphere is not going to change, it will remain as it is, right. Now if you say that if this is the center and if you take this as a radius and if you draw it, so the circle size will become less as compared to this, but some portion has to be there below the diagonal. So that is why this sphere will look like exactly the circle. See, आपके सामने ये चीज है ना, ये ऐसे है ना. तो अगर if this is a sphere, if you tilt it anyways, the radius is not going to change. You can see that. कहाँ से बदलेगा, नहीं बदलेगा ना. आप इसको ऐसे रख लो, and if you topple it also, so whatever be the size, whatever the circle you are seeing, it is not changing, isn't it? The radius is not changing. So obviously it's isometric projection, even though you have scaled it, the radius is not going to change. So this is very, very important that you have to understand. So a sphere is a special case. Apart from a sphere, if you do anything with any other object, the radius will change. So two important points. First, isometric projection is drawn on the iso scale of 0.816. Second, the sphere will look as it is in the isometric projection. There will be no change in the shape and size of the sphere, because the sphere, if you tilt it anyways, it will look like a circle of its own radius. There is no doubt about it. I hope it is clear. Then what is isometric view? Isometric view. Isometric view is drawn on its true length. Isometric view is drawn in true length,
right? Now you will ask, sir, why true length? Because this is what we are going to see. Yes, that's correct. When an object is tilted, you will see this, not the one that I am going to draw. When we use CAD tool, to draw the isometric, we don't scale it first. First we draw on the true length, and then by a single button we scale it down. Correct? Except sphere, everything will get scaled. Right? Now in the exam they will ask you, what is the difference between isometric view and isometric projection? So you should know what is isometric projection. So isometric view is drawn on its true length, isometric projection is drawn on its scale, isoscale. Right? So let us see how to draw this one. I hope things are clear till here. Any doubt, anybody? So first you draw correct. So this length will be at 50. This length will be at 50. This angle is 30 degree. This angle will be also 30 degree. This length will be also 50. Right? If I talk about the center, center will be also at 50. सेंटर जो होगा है ना इससे बड़ा होगा, दिस वाज O. ये डिस्टेंस भी कितना 10 है ना, दिस विल बी एट 10. राइट. सो आइसोमेट्रिक व्यू, everything will be drawn on the isometric length, sorry, or will be on the true length. जो एक्चुअल लेंथ है उसी पे हम ड्रॉ करते हैं. इन आइसोमेट्रिक प्रोजेक्शन इट हैज टू बी स्केल्ड. इन आइसोमेट्रिक व्यू नो स्केलिंग इज डन, एवरीथिंग इज ड्रॉन इन ट्रू लेंथ. नाउ सी, even the center is at 10 centimeter or 10 millimeter above, here I have scaled it, but here no scaling. Now I told you earlier that some portion of the sphere should lie below xy line, isn't it? So if I draw it, what you can see, some portion should be drawn below xy line. थोड़ा सा और बड़ा बनेगा नहीं, some portion. So what it is becoming? So you can see that this size has increased, this spherical radius, isn't it? So it has increased. ये तो बड़ा ही हो गया पहले से. अब ये क्या कश्मकश है, isn't it? It has increased. So this is how much? It is your one spherical radius 10. Correct? इसको हम लोग दिखाते हैं spherical radius 10. यानी कि ये 10 से बड़ा हो चुका है जहां पे, राइट. सो ये 10 से बड़ा हो चुका है, यानी कि इसकी साइज, द सर्कल साइज हैज इंक्रीज्ड. हाउ इज इट पॉसिबल, है ना? सो दैट मीन्स इन आइसोमेट्रिक व्यू ऑफ ए स्फीयर इट इज लार्जर देन इट्स ओन साइज. ये बिल्कुल वैसा ही, आप इसको एनालॉजी से ऐसे समझो. ऑन अ क्लियर डे, एवरी डे इन द नाइट यू विल सी मून, है ना, चांदनी रात में आपको, या फिर इन द नाइट व्हेन यू सी द मून, so it is of the same size every day, but certain days are there in which the size of the moon is larger than that its original size, है ना. होता है ना कभी कभी, जैसे कि पूर्णिमा में होता है ना, या फिर कभी ऐसा होता है, कोई होता है ना कि 30 साल के बाद एक ऐसा दिन आएगा जिसमें चांद का साइज बहुत बड़ा दिखेगा. ऐसे एस्ट्रोनॉमी होता है, न्यूज में आता है इस तरीके से, राइट. सो एवरी डे इफ यू लुक एट द मून इट इज ऑफ द सेम साइज, बट देयर आर सर्टेन डेज इन विच द साइज ऑफ द मून इज लार्जर देन इट्स ओन साइज. डज दैट मीन दैट द फिजिकल dimension of the moon has increased? No, it does not mean at all. Physical dimension of the moon is same, right? Sometimes it is looking like a small every day, sometimes it looks larger. Exactly the same thing. You can use the analogy, right? This is basically analogy. So that means every day I am seeing the moon like this, but certain days I am seeing the moon larger than its own size, right? So that is isometric view and isometric projection. Clear? Now, 2 or 3 things that you have to. Now, what is 1 SPH? This 1 SPH, it is called a spherical radius, is equal to root 3 upon root 2 times of true length. That is approximately equal to 1.11 times of true length, right? This is approximately 1.11 times of true length, 1.22, right? So that means the radius has increased by one factor of 1.22, right? So what we can conclude is that there are 2 important things that you have to understand. The isometric view or the isometric projection of the sphere is of the same size, but the isometric view of the sphere is larger than its original size. Second point, the isometric view of an object looks larger as compared to the isometric projection of that object. बताओ ये चीज समझ में, ये दोनों पॉइंट मैं लिखवा देता हूं. So first you understand this thing. Clear? So isometric projection of a sphere is a circle of same radius, but isometric view of a sphere is larger than its actual radius. Clear? Second point, isometric projection is drawn on a scale of 0.816, whereas isometric view is drawn on true length. Hence, isometric view of an object is larger than isometric projection, than its isometric projection. रोहित शर्मा क्रिकेट छोड़ के यहाँ पे आ गया पढ़ने. आइसोमेट्रिक प्रोजेक्शन और आइसोमेट्रिक व्यू में क्या डिफरेंस है? ये डिफरेंस है, आइसोमेट्रिक प्रोजेक्शन जो होता है इट इज ड्रॉन ऑन अ स्केल ऑफ 0.816, बट आइसोमेट्रिक व्यू इज ड्रॉन ऑन इट्स ट्रू लेंथ. So isometric view will look larger in shape and size as compared to the isometric projection. That is the difference between isometric view and isometric projection. ऊपर वाला लिख नहीं पाए, लिखो, लिख लो, ड्रॉ कर लो, आराम से कर लो. हाँ, तब तक हमको थोड़ा गले का रेस्ट भी मिल जाएगा. सचिन सर, मैं भी मोहल्ले का गली क्रिकेट छोड़ के आया हूँ पढ़ने. अच्छा किया कि आप क्रिकेट छोड़ के पढ़ने आ गए. क्योंकि आपको समझ में तो आ गया कि आपको आपके लिए पढ़ाई बेहतर है कि नहीं सचिन? सेकंड पॉइंट में आइसोमेट्रिक व्यू नहीं. अरे कौन भाई साहब? ऋत्विक नयन, आइसोमेट्रिक व्यू थोड़े ना ड्रॉ करते हैं 0.816 पे. आइसोमेट्रिक प्रोजेक्शन इज ड्रॉन ऑन 0.816. आइसोमेट्रिक व्यू इज ड्रॉन ऑन ट्रू लेंथ ओनली. आइसो देखो, see this figure, isometric projection I have drawn at 0.816 and isometric view is drawn on true length. Done everyone? Chalo, next. So isometry is completed. Next we have diametric and trimetric projection. इसमें ज़्यादा कुछ याद नहीं करना. Two things you have to remember. One is condition and one more point. So in diametric projection, in diametric you have only two sides equal, right? OA and OB will be equal, but OC is not equal. OA, OB and OC will be equal. So if OA and OB are equal, right? So alpha will be beta not equal to gamma. Angle A will be equal to angle B, but it is not equal to 30 degree, right? Second point, two diametric scales are used. These are the two things that you have to remember. And the last one is your trimetric projection. लास्ट जो है ट्राइमेट्रिक प्रोजेक्शन. Condition. OA not equal to B not equal to C, alpha not equal to beta not equal to gamma, angle A not equal to angle B. Three trimetric scales are used. Three trimetric scales are used. So this is the end of this chapter. तो आपके वर्कबुक का 3 चैप्टर हमने कवर कर दिया. सर क्यूब विल आल्सो लुक बिगर देन आइसोमेट्रिक व्यू. यस बिल्कुल कार्तिक अरविंद, क्यूब भी तो बड़ा दिखेगा ना, बिकॉज क्यूब यू आर ड्राइंग ऑन ट्रू लेंथ. इन आइसोमेट्रिक व्यू, इन आइसोमेट्रिक प्रोजेक्शन इट इज ड्रॉन ओनली इन द ये स्केलिंग फैक्टर. ठीक. So next we will go to the projection of points. Done, everyone? Clear? Shall we move forward to the? तो आपके वर्कबुक में टोटल 3 chapters we have covered. So there are what are those 3 chapters? The first chapter, so you have learned only one chapter, chapter number 5, but in the workbook there are 3 chapters that we have completed. First, orthographic projection, there will be one chapter. Second, chapter number 12 I guess, or 12, chapter number 12 isometric, and chapter number 13 isometric projections. 3 चैप्टर आपके वर्कबुक का हमने कंप्लीट कर दिया. एक ही हमने किया एक चैप्टर, लेकिन हुआ 3. सुनंदा कुमारी, थैंक यू. चलो. सो नेक्स्ट, ओके, ये नेक्स्ट ही था. प्रोजेक्शन ऑफ पॉइंट्स. ठीक है, प्रोजेक्शन ऑफ पॉइंट्स. सी, प्रोजेक्शन ऑफ पॉइंट्स में 2 चीज हम लोग पढ़ेंगे. क्या है वो चीज? So 2 things we are going to discuss. First, point in a specific quadrant. Point in specific quadrant means what? It means that suppose this is your xy, this is HP, this is VP, correct? Point A, B, C, D, correct? And the second one, point lying in POP, जैसे कि VP, HP, XY. A, B, C, D. Right. Now, before going deep in the subject or understanding the thing, how we are going to do it, let us clear a little basic concepts. कुछ basic चीज हमें पता होना चाहिए, right? So these are the two things that we will cover. So you can see that we have covered all the segment of the points, right? So that means if the point either it is in specific quadrant or it is lying on in POP, right? इससे क्या हो जाएगा, पूरा चीज हम easily handle कर सकते हैं. So but before going to that, let us have some basic concepts. Right? Basic concepts. So basic concepts में number 1. Right? So symbols and abbreviations and its abbreviation. See. So let us take an example. So this is the vertical plane, this is the horizontal plane, here is the observer. This is XY. Point is here, point is here, point is here, point is here. Right. So we have 4 points A, B, C and D. Correct. Symbol and abbreviation. ठीक है, तो देखो फर्स्ट सिंबल इज upper arrow, correct? So upper arrow, you can see that here, this is the upper arrow. So how you will read this upper arrow? Upper arrow means above HP. So this A point is above HP, B point is above HP. So upper arrow means above HP, right? So upper arrow, it means above HP. Similarly, down arrow below HP, below HP. Next, this arrow in front of VP, in front of VP, in front of VP. Behind VP, behind VP. correct? Basic concept number 1. And basic concept number 2, nomenclature of point. Clear? Now nomenclature of points. So let us see what is the meaning of this. Let us take an example. Let us point P, it is 10 mm above HP, 15 mm in front of VP. That is the meaning. So 10 mm above HP and 15 mm in front of VP. So let us draw its. So first I will draw in 3D. This is VP, this is HP. Correct? Observer is here. For this observer, this will be RPP. So I am taking first quadrant, right? Obviously, so what I have to do is, this point is 10 mm above and 15 mm in front. Correct? So this is this point object 10 mm above HP, 15 mm in front of VP. So this is the actual location of the point, isn't it? This is the actual location of the point P. Agree? Isn't it? So 10 mm above HP and 15 mm in front of VP. अच्छा, आप लोग नोट नहीं कर पाए? जल्दी करो, अभी तक यहीं पे हो? ओ भाई साहब, ताड़ाताड़ी करो भाई, ऐसा कैसे होगा? जल्दी लिखो. ठीक हो गया, डन। Now coming to nomenclature of points, ठीक है। See nomenclature of point. So nomenclature means अपने chemistry में नाम सुना nomenclature, nomenclature means to name something. See, this is the point I have taken one example, point P, 10 mm above HP, 15 mm in front. So 10 mm above HP, 15 mm in front. This is the position of the point. Now when this observer is going to look at this particular point, its projection will be seen over here, isn't it? So its projection will be seen here. Similarly, when this observer will go on the top and see this same object, so what is the projection he will see? He will see somewhere here, isn't it? Fine. Now if I name it, so you will call this as front view or elevation, and this one you will call it as top view or plan. Now when the observer comes towards the left side, so this is a left side view, this is a LSV, left side view. So where will be its projection, right? So its projection, correct? So here will be its projection, isn't it? So this view will be called as left side view. Now rather than calling front view, top view, left side view, let us rename it. Rename in the, what is the meaning of this? So it means that if I am going to project it, right, if I am going to project this point, so anything that will be drawn on the front view will be represented with a small letter and a dash. That is nomenclature. Anything, because देखो, it is a simple point. If there are number of points, if there are solids, if there are planes, so there will be number of points, right, number of corners. So number of objects to be drawn on the front view. Every time you cannot write front view, front view, front view. It will not make any sense. So that is why we have to name it. So projection of point will be on the vertical plane. It will be represented by a small letter with a dash. Similarly, anything that you are going to draw in the horizontal plane, it will be only written with small letter. And anything that you are going to draw on the profile plane, it will be small letter with double dash. This is called as nomenclature. So nomenclature means what? Actual point is shown by the capital letter. The front view or the anything that you are going to project on the vertical plane is shown by a small letter with dash. Anything you are going to project in the horizontal plane, it will be represented by small letter, and anything you are going to represent in the profile plane, it will be represented by small letter with double dash. ये सारा चीज मैं लिखवा दूंगा, don't worry, I will make you write everything. So just understand these things. Now we need to convert this into multi-view orthographic projection. Multi-view orthographic projection. So for this, what you have to do? For this, I have to rotate HP in the clockwise direction and profile plane away from object, isn't it? This is what concept you have learned in the last chapter. That means this HP has to be rotated in the clockwise direction and this profile plane will be rotated away from the profile object, correct? So what the shape I am going to get? This is X, this is X, and this is Y, correct? So this is the vertical plane, okay. This is the horizontal plane, and towards right of the vertical plane is your right profile plane, correct? If you remember, I said that we have to draw a meter line to draw the side view. 45 degree पे, correct? So this is a meter line, and I also told you that in the projection of point I will tell you why we use 45 degree, isn't it? This is a meter line that we already know. and I told you in the projection theory of projection that I will tell you in projection of point that what is the utility of this meter line, correct. xy, so this is x1 y1, clear till here. क्लियर. नाउ सी एक चीज और ध्यान देखो से देखो मुझे बताओ, इफ दिस इज 15 ये बॉट ये इफ दिस इज 10 दिस विल बी हाउ मच, यू विल से इट इज आल्सो 10. इफ दिस इज 15 हाउ मच इट विल बी 15. इफ दिस इज 15 हाउ मच दिस विल बी, it will be also 15, isn't it? If this is 15 15 15, if this is 10 10 and 10, correct. Okay, now if I call it as, let us say this is x distance, so how much it will become? It will become your x, isn't it? You can see it very carefully. Now see how to draw it. See, देखो from xy line, this is xy line, you can see it here. This is your x and this is your y, and this is your x1 and this is your y1, correct. So this is your xy line and this is your x1 y1 line, correct. From xy line how much above is p dash? You will say 10, isn't it? So I will draw a line, correct, of length 10, and I will put the point over here. This point is your p dash, or you can say that this is front view or elevation, clear. So from xy line this p dash is at 10. From xy line how much is this small p? Small p is in hp, so hp is rotated, so it is at 15, right. So that means this distance is 15, correct, and this point is how much? This point is your p dash. So this is your top view or plan, isn't it? So I have drawn it. So this is your 10 and this is your 15, drawn, correct, because HP is rotated, so it is showing. Now I told you that I told you to draw the side view. First what you have to do? You have to draw the projectors like this. You have to draw projectors like this, isn't it? And from here you have to join projector like this, correct. So this is the intersection of the two. So this is your P double dash and this is your left side view, because RPP पे क्या मिलता है? Left side view in the first angle projection method. So right side view, sorry, left side view is obtained in RPP. Now this is 45. So at 45 degree you can see that P double dash. Now I will tell you, so this is the projection and this is basically called as nomenclature. Now the question arises here, why I have taken 45 degree? Now see very carefully, here you will get the real meaning of 45 degree. Now if this is 45 degree, how much is this angle? You will say this angle is 90 degree, isn't it? So if this is 45 degrees, what is this angle? It is 90 degree. If it is 90 degree, then how much is this angle? You will say this angle is also 45 degree. There is no doubt about it. ठीक है, यहाँ तक पहले बना लो. So I am going to tell you what is the significance of 45 degree. Why we have taken 45? Why not any other angle? Why not 30 degree? Why not 60 degree or so on? 45 ही डिग्री क्यों लिया गया है? ये हम लोग समझने की कोशिश कर रहे हैं। क्लियर? ठीक है यहां तक? अब देखो, all angle. Now if this is 45 degree, so can you tell me how much angle is this one? You will say this is also 45 degree. This angle is how much? 90 degree. So this angle is how much? It is 45 degree. So you can see that this side and this side both are equal because it is an isosceles triangle, and since this side is parallel to this, so all the sides are equal, isn't it? So that means it is forming a square. It is forming a square, and this is the diagonal of the square, and all the sides are equal. What does that mean? It means that whatever be the length, so this length is how much? 15. So this length will be how much? So if this length is 15, and since it is forming a square, so how much will be this length? You will say that this length will be also 15, isn't it? So if this is 15, so it is an isosceles triangle, so this side, or you can say that this complete is a square, so it is a square, so it is 15, so automatically it will become 15. If it is 15, then how much is this distance? How much is this distance? You will say that this distance is 15 as well, isn't it? This distance is also 15. So this 15 is reflected where? Here, right? So the distance of the top view from x1 line is same as the distance of the side view from x1 y1 line. X1 y1 line is called as side reference line. So the distance of the point or the top view from xy line is same as the distance of the side view or the left side view, or you can say that the distance of the side view from x1 y1 line or side reference line. That is correct? फाइन, यहां तक तो समझ में आ गया। अगर ये 45 लेते हैं, जरा इसको इसमें बैक ट्रेस करके देखते हैं। ये डिस्टेंस कितना दिया रखा है? 15 है ना। x1 y1 से व्हाट इज द डिस्टेंस ऑफ p डबल डैश? 15. द सेम थिंग आई एम गेटिंग ओवर हियर. इट मींस द प्रोजेक्शन इज करेक्ट, and this is possible when the angle is 45. If you take 30 degree or 60 degree, it will be not a square. So suppose you take 30 degree, so it will become 60 degree. So obviously you have to take the components, right? So it will be not 15 anymore. It will be, the value will be changed. That is why it is taken 45 degree. I hope now it is clear why we take the 45 degree. तो ये सारा पॉइंट मैं आपको लिखवा देता हूँ, ठीक है। क्लियर? अच्छा, तो ये डिस्टेंस कितना होगा? सो दिस डिस्टेंस विल बी योर x, isn't it? p डैश, इट विल बी योर x. क्लियर? समझ में आ गया? तो चलो, सो आई विल मेक अ पॉइंट. सो फर्स्ट पॉइंट, द एक्चुअल पॉइंट इज रिप्रेजेंटेड बाय, the actual point is represented by capital letters, by capital letters. Example A, B, C, D and so on. Fine. Second, front view at VP. Represented by small letters with a dash. Example A dash, B dash, C dash इत्यादि. समझ रहे हो कि नहीं? जो लोग का छूट गया वो लोग लिखते रहिए. टॉप व्यू कहां पे मिलता है? एट HP. रिप्रेजेंटेड बाय स्मॉल लेटर्स ओनली. एग्जाम्पल के तौर पे A, B, C स्मॉल. तुषार अग्रवाल. ठीक है, नोट इट टिल हियर. third, fourth. Side view at profile plane, represented by small letters with double dash, with double dash. For example, A double dash, B double dash, C double dash, etc. Fifth, significance of 45 degree. Significance of 45 degree. Distance of top view from XY line, that is a reference line, is equivalent to distance of side view from X1 Y1 line. That is side reference line. Correct? So let us solve one question based on this concept. In projection of क्या नाम इसका lines, page number, सर projection of points पढ़ रहे हैं हम लोग. Projection of point, page number, ये कौन सा है, 16, question number 6.32, page number 16, question number 6.32. Draw it. Page 16, question number 6.32. देखो, I hope things are clear till here. So in this a figure is given. It's a very good question for understanding purpose. X1, Y1, X, Y. Correct. So here this is given A double dash, this is given A dash. Correct. Further, this length is given as 40, this length is given as 20, and this length is given as 50. Correct. Now they are 50 and a half. Now they are asking which of the statement is wrong. Wrong. So point 40 is in front of VP, point 50 फलाना ढिमकाना जो चार चीज दे रखा है. This is the question that has been given. Now they are asking about the location of the point. Where is the actual point, right? So it is a good question because this is incomplete. So first we have to, this is given in orthographic projection because you can see that side reference line XY is given, right? So let us see how to solve this kind of question. तो देखो सबसे पहले क्या करेंगे हम, यहाँ तक तो क्लियर है. Now let us complete this figure first. This is the half done. So what you have to do is, so you need to draw a line like this, right? Or first you draw a meter line at what angle? 45 degree. Correct. From here you draw the projection over here. right? So this is the basically your point, isn't it? So this point is your A, right? Now this is A dash, means it is the front view, correct? So this is your A dash, means it is front view or elevation. This is A double. Now you can see that if this is the front view or elevation, that means this is the vertical plane, this is the top view, isn't it, or plan. So this will be your HP. We know that right to the VP, right lies RPP. RPP, so any projection on RPP, it is your left side view, right? Because it is the first angle. First angle means RPP will be right, right? So this is the VP, this is HP, and towards the right of the VP is your LSV. So this is the complete structure that we have done. Now if this is 50, so how much will be this one? This will be also 50, isn't it? This will be also 50. So now what I have to do is, now let us convert it into 3D figure, correct? So let us convert it into 3D. This is VP and this is HP. And this is what? This is your RPP. बताओ यहाँ तक clear? Any doubt till here? देख लीजिए. Clear है यहाँ तक? So I hope everyone is clear. Now see, point is 40 mm above, correct? अब देखो कैसे बनाते हैं इसको. See very carefully. Point A dash is 40 mm above XY. So this is XY. This is your A dash. How much? 40 mm. 50 mm is A. This is your A. How much? 50. So this will be also 40 and this will be 50. So actual point is somewhere here. This is the actual point A, isn't it? Clear? Now we have to draw side reference, correct? So this point will be how much? It will be your A double dash. So if this is 50, so this will be 50 also. So that means this is 50. So this value, ये जो दे रखा है वो क्या है? ये जो दे रखा है, this one, it is 20. So A dash. So this will become your 20. So therefore this will become your 20. So this is the projection. Now you can answer the question. Rohan Chaudhary, sir, in first quadrant at a distance 50 to VP and 40 from HP and 20 to PP, correct. Rohit Sharma, sir, 5-point repeat. Okay, I will repeat. But which answer is correct? Which answer is correct? Muhammad Saqib is saying option D. आपको, that means the statement which is wrong, that is the correct answer. Which the statement which is wrong, that is your correct answer. तो बताइए कौन सा है? समझ में आ गया? I hope things are clear. right? So Kasturidas is saying B. Let us see. Point is 40 mm in front of VP. Point is 40 mm in front of VP, तो गलत है ना? Point is 50 mm in front of VP. गलत जो गलत है वही आंसर. This is one, right? First statement is wrong. So whichever is wrong, that is the correct statement. Point is 50 mm in front of VP. That is correct. So this is your wrong. That means it cannot be the answer. Third, distance of point from side reference plane is 20. Distance of point from side reference plane is 20. That is correct. And fourth, a distance of point from side reference plane is 50. No, that is wrong. So this is correct. So answer is 1 and 4 because it is said that which of the following statement is or are wrong. तो जो गलत है वही सही है. Answer is D. Any? So answer is D. Any collaborate D? Yes, correct. D is the correct answer. है कि नहीं? आसान था, मजेदार था. Okay, Rohit Sharma. See, significance of 45 degree, what I said that the distance of side view from side reference line, ये distance बराबर होंगे ना. अगर ये 45 डिग्री है, so ये जो लंबाई है, ये लंबाई और ये लंबाई दोनों बराबर हो जाएंगे because it is forming a square. सारा एंगल कितना है? 90 डिग्री, so it is a square. So ये जो लेंथ होगा वही लेंथ आपका ये हो जाएगा. यानी कि अगर ये 15 है तो ये भी लेंथ कितना हो जाएगा? 15 ही होगा. यही तो आपको दिख रहा है ना, ये भी 15 है और ये भी क्या है? 15. सी द डिस्टेंस ऑफ P is 15. द डिस्टेंस ऑफ P डबल डैश इज आल्सो 15. द डिस्टेंस ऑफ ओके ये सिर्फ यहाँ डैश नहीं होगा, यहाँ डैश नहीं होगा. इट इज अ टॉप व्यू, राइट? सो दिस इज अ P, दिस इज ओनली P, दिस इज नॉट P डैश. सो ये जो स्मॉल p इट इज 15. तो स्मॉल p कितना डिस्टेंस है? XY से. सो फ्रॉम द XY दिस डिस्टेंस इज 15. From XY this distance is 15. From X1 Y1 how much is P double dash? It is 15. So it is 15. So ये distance क्या होगा? बराबर हो गया. That means the distance of the top view from X1 Y1 line is same as the distance of the side view from X1 Y1 line. Distance of top view from X1 line, that is reference line, is equal to distance of side view from X1 Y1 line, that is side reference line. यही चीज लिखा है. Significance of 45 degree. Clear? चलो आगे चले. ठीक है. तो अब मेरे समझ से आपको चीज समझ में आ गई होगी, है कि नहीं? सो यू कैन सी दैट इंजीनियरिंग ड्राइंग हर एक कदम पे देयर इज अ ड्राइंग, राइट? हर एक कदम पे आपको ड्राइंग मिलेगा ही मिलेगा, करेक्ट? सो एट एवरी स्टेप यू कैन सी दैट. सो 1 or 2 days back some student were saying, राइट? तो अब ये बताओ कि क्या आपको लगता है कि इफ आई गिव द रेडीमेड फिगर यू विल बी एबल टू अंडरस्टैंड? नो, जब तक आप खुद से नहीं बनाओगे तब तक समझ में नहीं आएगा. सो हियर रेडीमेड डायग्राम्स आर नॉट recommended because you will not understand anything. You will see the figure and in the examination you will get confused. Now you have drawn it, it will remain in your brain, right? जब तक खुद से नहीं करोगे तब तक आपको नहीं समझ में आएगा, right? So ready-made figures are necessary in which basically the static figure is there or the figure that will not just give you the ideas. Here you have to construct according to the question, you have to construct it. So until and unless you know the basic thing, you will not able to solve any question, right? And you are practicing here so that you don't have to draw figures in the exam. You are drawing figure here, right? When you see the question you don't have to draw, only in the mental picture it will create. दिमाग के अंदर ही आपका पिक्चर बनना शुरू हो जाएगा. Okay, this is going to happen and you will get the answer, right? Okay, so clear? Now let's go for the analysis. See, so case 1, the first one we will take point in specific quadrant. Point lying in specific quadrant. So I remember when I was in college in the engineering drawing exams, right? So I lost 4 marks in this projection of points. I still remember, right? So actually we had a paper of 100 marks theory means and 25 marks practical also. So out of 125 I got 121 in engineering drawing. 4 marks I got deducted in this projection of points only due to overconfidence, because I thought point ही तो है, कौन बहुत बड़ा चीज़ है, और उसी ने आईना दिखा दिया, राइट? सो होता ना, किसी को छोटा नहीं समझना चाहिए, सब अपने में बहुत ही धांसू है, right? So point lying in specific quadrant. So let us understand. Let us consider an example A. Let us say A is a point which is 10 mm above HP and 15 mm in front of VP, right? So point lying in specific quadrant. Let us consider A 10 mm above HP and 15 mm in front of VP. Draw its projection. Draw its projection. और वो 4 मार्क्स जो कटे थे वो प्रैक्टिकल में ही कट गए थे, राइट? फाइन. सो देखो, इस क्वेश्चन, ऐसे क्वेश्चन को करने का तरीका क्या है ये समझ लो. फाइन. सो इट इज वेरी सिंपल टेक्निक. आई विल गिव यू वन टेक्निक एंड ऑल द क्वेश्चन विल बी सॉल्व्ड ऑफ प्रोजेक्शन ऑफ पॉइंट्स, है ना? आदमी गलती से सीखता है ना. दिस इज वीपी, दिस इज एचपी, करेक्ट, एंड दिस इज द ऑब्जर्वर. This is xy, correct. So I will give you one technique, and this one technique will give you the whole idea how to solve the question. See very carefully. Where is the point? So point is 10 mm above and 15 mm in front. 10 mm above, 10 mm above which 15 mm. Okay. This is your 10 mm above and 15 mm in front of VP, right? So this is the basically point A, isn't it? So point A is 10 mm above HP and 15 mm in front of VP. Clear? Now if you see the front view of this, you will get A dash. A dash is nothing but your front view or elevation, correct? And when you are going to see from the top, you will see the top view over here, A, which is your top view or plan, isn't it? Clear? So just one second. Clear? Now see, ठीक है यहाँ तक? So 10 mm above HP and 15 mm in front. So A, if you project it here, you will get the A dash, and this is the front view and top view, right? Now this is the initial condition that has been given. What we know is, we know that HP is rotatable. आप HP को क्या करो? Rotate कर दो. कैसे? Clockwise. If HP is rotated, what will happen? So this point A, it will come down, isn't it? So if you are going to rotate this, it is not going to change, it will change. That means A dash. So A will come here. So this distance is how much? This is 15. So therefore that means from initial to finals, listen very carefully, initial to final, HP has to be rotated in the clockwise direction, correct? So that means initial condition to final condition. Initial condition means what? It is in the 3D. Initial means 3D. Final means it will be 2D. 2D means orthographic. 3D means it is non-orthographic, right? So initial to final. So when I am going to convert into final, so HP will be rotated in the clockwise direction. So as you are going to rotate in the clockwise direction, this point will come down, right? So that means how the figure will look like. So the figure will look something like this. Right, so the figure will something like this. See very carefully. This is the intersection XY. There is no doubt about it. Right. Now this point A dash, this is your A dash, which is the front view or elevation, where we draw it at VP, and this is how much height. This height, if this height is 10, so this height will be also 10, है ना? तो ये height कितना हो जाएगा? So this height is at 10, correct? Similarly, we have A. A will be somewhere here. A will be somewhere here. Top view or plan. This one we are going to get at HP, right? So how much distance is this one? So this is at 15, isn't it? Correct? So this is the final view. This is the final, or you can say that orthographic view, right? So this is the final or orthographic. Now, correct? So initial to final. Now in the examination, they might give you this situation, they might give you this situation. So according to the question, when you read the question, then you will come to know whether this part is given or this part. We will solve one question, then you will come to know, right? Initial to final. Now, if suppose anybody asks you, if I am going to draw from final to initial, that means orthographic to the 3D, right? So orthographic means VP HP should be in one plane. That is the meaning of the orthographic. Orthographic में VP HP एक ही plane में होता है. You can see that in the same plane VP and HP is here, but here VP and HP are orthogonal to each other. So if I am asking you from final to initial, what you have to do? Obviously, you have clockwise rotated. So if I anti-clockwise rotate the HP, यहाँ पे देखो HP has been rotated clockwise. So here, if I rotate it anti-clockwise, then you will get this figure. So that means in this particular case, HP need to be rotated in the anti-clockwise direction. बताओ clear है चीज? Is it clear? Right. So one question we will do. Question number, I will tell you, just 1 second, let me see. Question number 18. Question number 18. Let us do question number 18. ठीक है, मैं आपको समझाता हूं कि किस तरीके से क्वेश्चन को पढ़ते हैं, राइट? आई होप थिंग्स आर क्लियर. सो यही एक मेथड, दिस ओनली मेथड यू हैव टू अंडरस्टैंड. एक मेथड समझोगे सारे प्रोजेक्शन ऑफ पॉइंट से क्वेश्चन बन जाएंगे, राइट? एंड वन थिंग दैट बेसिक कॉन्सेप्ट इज ऑल्सो रिक्वायर्ड. विदाउट बेसिक कॉन्सेप्ट दिस थिंग्स आर नॉट राइट. आई होप इट इज क्लियर. बताओ किसी को डाउट है? See, what is question number 18 saying? कहाँ है ये रहा? If the front view of a point is 40 mm, read the question and try to draw it. Figure it out. यहाँ तक समझ में आया किसी को? बताओ कोई डाउट है? Shall we go ahead? Shall we move forward? ऋत्विक नैन 6.32 फिर से एक बार बता दीजिए, और 6.33 तो आप खुद से ट्राई कीजिए, क्योंकि 6.32 जैसा ही है वो चीज. 6.32 मैं आपको समझा दूंगा, क्लास खत्म होने दीजिए उसके बाद, ठीक है? अनूप मलिक सर 0.5 एक बार दिखा दीजिए 2 सेकंड के लिए. सब दिखाएंगे, है ना? जस्ट वेट. बताओ ये क्वेश्चन में 18 करें? ओके, आंसर भी आ रहा है, इसका मतलब आप लोग कर रहे हो बैठ के, है ना? हम सोच रहे हैं कि आप लोग नोट ही कर रहे हो. बताइए कैसे होगा ये. सी क्वेश्चन नंबर 18. क्वेश्चन नंबर 18 क्या कह रहा है? लेट अस अंडरस्टैंड फर्स्ट. First understand what it is given in the question. Question is saying that, question number 18, if the front view of a point is 40 mm above xy line, so this is the xy front view of a point, let us say a dash. A dash क्या है? Front view और elevation कहाँ पे बनता है? VP में. It is how much? 40 mm above xy and top view is 50 mm below xy. Top view. Top view मतलब A. Top view प्लान कहाँ पे बनता है? HP में. कितना है? Below 50 mm below xy. The position of the point, isn't it? तो अब ये बताओ कि आपका कौन सा सिचुएशन दे रखा है. This is orthography given. Orthographic means final situation is given. They are asking where is the point. So how to locate the point? Locate the point, that means you have to go in 3D, right? So what you will do? So here, since HP is there, you have to, so from initial to final I have to go. Sorry, this is final to initial जाना पड़ेगा ना हमें, right? Because the final means orthographic, because everything we have to draw orthographic. Orthographic से कहाँ पे जाना है? 3D में जाना है. तो final to initial. So what you have to do? You have to rotate HP in the anti-clockwise direction, है ना? So once you rotate HP in the anti-clockwise direction, you are going to get this kind of figure, right? So this is your XY. This will become HP and this will become VP, isn't it? Now where are the points? Points 40. So let us say this is your A dash and this is at 40 and this is your 50 and this is your A. This is how what it will happen. So where will be the point? So if you see the point, isn't it? So this is the location of the point. This is your A. So this is your 40 and this is your how much? 50. So which option is correct? So they are saying that the first option 40 mm above HP. Yes, option A is correct. 40 mm above HP. Answer A. है कि नहीं आसान? कुछ करना पड़ा आपको? ज़्यादा कुछ नहीं करना, बस you have to draw it. Whatever the question is saying, try to draw it. Then you will come to know whether I have to rotate or whether I don't have to rotate. इसमें rotate करना है. Why? Because they are asking the position of the point. So how you will come to know where is the position of the point? So to know where is the position of the point, you have to rotate. You have to make 3D. Then only you will come to know where exactly is the position. Right? I hope things are clear. So this is for A. Correct? Now coming to B. Clear है सबको? बचवा लोग बुझे कि नहीं? So क्या लिखा है? इसमें आप ऐसे लिख लो इसको. So if possibility is there, then just put one line. A point lying in first quadrant. Correct. So here I missed one line. Point lying in first quadrant. So just put one line. Point lying in first quadrant. So I have taken an example. This is an example. Point lying in first quadrant. ठीक, बस you write one line. Point lying in first quadrant. And as an example, I have taken this an example. You can see 10, 15 ये अपने मन से लिया. You can take any values of your choice. It is not important that you have to take 10, 15. You can take any value. एक example से हमने समझाने की कोशिश की है. तो this is how we have taken. Right, point lying in first quadrant. Now coming to B. Point lying in second quadrant. Point lying in second quadrant. Let us take an example. Same point, let us say B, 10 mm behind and 15 mm above. आ गया second quadrant? Correct. Draw its projection. Draw its projection. HP, VP. Observer, this is your XY. So point is 10 mm behind and 15 mm above. mm behind, 15 mm above. 10 mm behind, 15 mm above. So this point is your B. So you can see that the point is in which quadrant? It is in second quadrant. Clear? Fine. Now the projection of B, it will be a B dash, which will be a front view or elevation, correct. Now when the observer is going the top, correct, so where will be its projection? So projection will be somewhere here. So this will be your B, which is your top view or plan. Now if I talk about the dimensions, so if this is 15, so it will also become 15, and if this is 10, so it will also become 10, isn't it? Clear? Fine. So this is the initial condition that has been given. Now we know that HP is rotatable. So rotate HP. Where you will rotate? In the clockwise direction. As soon as you rotate it, so this is 10, so this point will go here, isn't it? So as soon as you rotate it, this is radius is 10, so it will go here, correct. So same situation, initial to final, what I have to do? I have to rotate HP in the clockwise direction, correct. So if I rotate it in the clockwise direction, so what you are going to get? So this is your XY. Point B dash, where it is? This is point B dash. Front view or elevation at VP. How much height? 15. So this height is how much? 15. Correct. Next point is your B. Where it is? So let us say this is B, which is your top view or plan, where you will get at HP. How much height? You can see that both VP and HP is lying above XY line. This is what I told you in basic concept of theory of projection. In theory of projection, I said that in second angle both VP and HP is lying above XY line. है ना, ये चीज़ बताया था ना आपको. कहाँ गया? अच्छा ये दूसरे पेज में, ये दूसरा पेज खुला हुआ है. Yesterday only I told you. अच्छा पता नहीं कहाँ चला गया, लेकिन आपको कल मैंने बताया था ये चीज़. आप देखोगे थियरी प्रोजेक्शन में, मल्टी व्यू प्रोजेक्शन के अंदर ये चीज़ हमने डिस्कस किया था, राइट. So this is a final, right. That means if I want to go from final to initial, what I have to do? HP has to be rotated in the anti-clockwise direction, correct. So you will get this value. Clear everyone? So this is for the point B. Clear? Coming for the point C. Point lying in third quadrant. Point lying in third quadrant. Yes, Tushar Agarwal. That's why we use first and third. Now, some of the students might ask, sir, if second angle is not used, then why we are solving question in this? It is just because the examiner wants to test your knowledge why second and fourth are not used. So if you know the story behind second and fourth, then you can easily solve the question. So examiner just want to know if point is in second quadrant, how to project it, whether it is used or not, that is the secondary. how to, if it is there, then how to use it, then only you will come to know why it is not used. So in the examination they might ask you about the point lying in the second quadrant, and they might ask you to project it, right? So you cannot challenge, because second quadrant is not, why are you asking, they are just asking to test your knowledge whether you know about the second quadrant or not, that's it, correct? Okay, now coming to the point lying in the third quadrant, let us say C is a point, third quadrant, right? So third quadrant means here, so 10 mm below, behind, and 15 mm below HP, third quadrant. So draw its projection, draw its projection. So we will complete the D ye charo karke, then we will end today's session, right? So point lying in third quadrant, so let us see. This is HP, observer, initial case, this is vertical plane, right? This is your XY, correct? So where is the point? So point is lying in the third quadrant, 10 mm and 15 mm behind, 10 idhar, 15 nahi, 10 पीछे 15 behind, below. So this is your 10 mm behind, 15 mm below. There is a point over here. This point is capital C. Let us say I am drawing C. So its projection, front view will be this one. So this is C dash. This is the front view or elevation, right? Now when the observer goes on the top and sees the object, right? So its projection will be seen somewhere here, isn't it? So this is C, which is the top view or plan. Now we know that HP is rotatable. So rotate HP in the clockwise direction. As soon as you rotate it, it will go above, isn't it? So this is what I am going to see. Okay, so what I can say is that from initial to final, HP needs to be rotated in the clockwise direction. Similarly, from final to initial, I can directly say that HP is rotated in the anti-clockwise direction, isn't it? Fine. So this is your XY, correct? Now where is your C dash? So C dash is here, 15 mm. C dash, this is the front view or elevation at VP, this is the final. What is the distance? So this distance is 15, and at a distance 10 we have small c, which is the top view or plan at HP. You can see that above XY HP, below XY it is VP, third quadrant. यही चीज आपको बताया गया था in theory projection. I have also told you that above XY is a HP and above below XY is the VP, opposite of first angle. You can see that exactly third angle. So this is how we can draw it. So simple technique to so we will solve one question, question number 28. So try question number 28 of your workbook, page number 15, question number 28. गुरदीप बम्बाल क्या लिखे समझ। सर बच्चे दुआ तो करते हैं आपकी कफ ठीक हो जाए जैसा आपने कल का, बट करते इतनी है ही है कि क्लास ड्यूरेशन तक ही चलती है। नहीं समझा क्या कहना चाह रहे हैं आप। चलो क्वेश्चन नंबर 28 करते हैं। आपका अगर जोक है तो मुझे थोड़ा समझने में टाइम लगेगा क्योंकि मेरा ध्यान इस क्वेश्चन को करने में है। चलो लेट अस सॉल्व दिस क्वेश्चन। सी क्वेश्चन सॉल्व करते हैं। बताओ व्हाट इज द आंसर फॉर क्वेश्चन नंबर 28। राइट, सो दिस इज द एक्स वाई। फाइन। नाउ व्हाट इट इज सेइंग दैट इन 3 डायमेंशन, 3 डायमेंशन मतलब क्या हो गया 3D। 3 डायमेंशन क्या होता है, हमेशा इनिशियल होता है ना। 3 डायमेंशन हमेशा इनिशियल होता है ना। ये इनिशियल क्या होता है, हमेशा 3 डायमेंशन का होता है। और फाइनल क्या होता है, हमेशा 2 डायमेंशन का होता है। फाइनल हमेशा किस डायमेंशन का होता है, 2 डायमेंशन, दैट इज ऑर्थोग्राफिक, है ना। ये हमेशा पता है हमको, ये ऑर्थोग्राफिक होता है। 2 डायमेंशन जो होता है ऑर्थोग्राफिक। कह रहा है इन 3 डायमेंशन शॉर्टेज डिस्टेंस ऑफ पॉइंट P फ्रॉम लाइन ऑफ इंटरसेक्शन ऑफ HP एंड VP। सो दिस इज VP एंड HP, लाइन ऑफ इंटरसेक्शन ऑफ VP एंड HP। ये कौन सा हो गया, दिस इज योर XY, है ना। तो XY इधर लिख लेते हैं। The shortest distance is 50 mm, point 30 mm is below HP and lies in the third quadrant. तो ये मान लेते हैं। So point is 30 mm below HP and the shortest distance is given as 50. ये दे रखा है ना। So this is the point P, correct। तो ये डिस्टेंस कितना हो जाएगा, ये 40 हो जाएगा। So that means this is 30 and this is 40. This is the actual position of the point P, correct। So if I draw the projection, इसका projection यहाँ पे आ जाएगा। So this will become P, right, और ये हो जाएगा P dash। फ्रंट व्यू और एलिवेशन एट VP, और यहां से देखेंगे तो क्या आ जाएगा, ये देखना। आपसे क्या पूछा है, एंड लाइज इन द टॉप व्यू ऑफ द पॉइंट इन ऑर्थोग्राफिक ड्राइंग। ऑर्थोग्राफिक ड्राइंग मीन्स व्हाट, ऑर्थोग्राफिक ड्राइंग मीन्स 2D। तो आप क्या करोगे, HP को रोटेट कर दो क्लॉकवाइज। सो HP शुड बी रोटेटेड इन द क्लॉकवाइज डायरेक्शन। कर दो रोटेट इसको। P पॉइंट कहां चला जाएगा, ऊपर चला जाएगा। VP HP XY, ठीक है। सो दिस इज अ P dash which will be front view or elevation. This is the final or orthographic. This is our orthographic, correct। at VP कितना 30 पे, और ये 40 है ना। P टॉप व्यू और प्लान एट HP कितना हाइट पे 40। क्या पूछा आपसे, सो व्हाट इज द क्वेश्चन, दे आर आस्किंग लाइज इन द वेयर द विल बी द टॉप व्यू ऑफ द पॉइंट। टॉप व्यू कहां पे होगा, सो टॉप व्यू ऑफ द पॉइंट विल बी 40 mm above XY line, 40 mm above XY line। ऑप्शन विल बी A, ठीक। ऑप्शन क्या हो जाएगा A, बताओ क्लियर है। अब आ जाओ लास्ट पे D, ठीक है। ये D आज के सभा का अंतिम। सो पॉइंट lying in 4th quadrant, point lying in 4th quadrant। क्लियर है सबको, बताओ क्लियर एवरीवन। ठीक है। नाउ पॉइंट लाइंग इन द 4th क्वाड्रेंट, HP VP, intersection is XY, करेक्ट. इनिशियल मतलब क्या हो गया, 3D प्लेन है ना. पॉइंट कहाँ पे लाई कर रहा है, सो पॉइंट इज ओके. ओहो, एग्जाम्पल तो लिखा ही नहीं मैंने. राइट, सो फॉर एग्जाम्पल D is a point 10 mm in front and 15 mm below. So 10 mm in front of VP, 15 mm below HP. ठीक, तो चलो इसको बना देते हैं. 10 mm 15 mm, 10 mm आगे और 15 mm. Fifteen, 10, 15, 10. Where is the point? D is here. So 10 mm behind, in front of VP and 15 mm below HP, correct. So front view will be here, D dash, this will be your front view or elevation, right. When the observer will go on the top, then the projection that it will be seen is your small d, which will be your top view or plan. Now we know that HP is rotatable, so rotate HP in the clockwise direction. As you rotate HP, what will happen, this point will come here, right. So therefore initial to final, HP has to be rotated in the clockwise direction, and final to initial, HP need to be rotated in anti-clockwise direction, isn't it? So this is your XY, this is the final. Final means ortho. Final means ortho, right. So where are the points? So point, you can see that D is how much, 10. D, this is the top view or plan at HP, right. So how much distance below? So it is your 10, isn't it? And another point is at 15, this is your D dash, which is the front view or elevation at VP, correct. So you can see the projection, and in the theory of projection also I told you the same thing, HP and VP, if it lies below XY line, HP VP, if it is lie below XY line, that means it is in the 4th quadrant, correct. So this is the final thing that we can discuss for today's class, right. So this today we will end here only, because there is no time for any other further discussion. If anybody has any doubt, they can stay here, else tata bye bye, see you tomorrow at the same time. Thank you.